this for me. All right, whatever. All right, so continuing our talk about probabilities. So we'll talk about just some basic rules for probabilities. So all possible outcomes together must have probabilities whose sum is exactly 1. Or instead of 1, you could think of 100%, right? Whether you think about the probabilities as decimals or as percentages, either is fine. So if I look at all the possible events, or all the possible outcomes, all those outcomes have to add up to be 1 or 100%. Certainly can't have more than 100%, right? And can't have less. So if all outcomes in the sample space are equally likely, the probability that event A occurs can be found using the formula. The number of outcomes corresponding to event A divided by the total number of outcomes in the sample space. Exactly like we had kind of done before. Remember we talked about flipping 2 coins and getting like heads and tails. Like there's 2 outcomes that do that out of 4. So it'd be 2 out of 4 because all flips are equally likely with a fair coin. And then the last one, probability that an event does not occur is 1 minus the probability that the event does occur. That's the complement rule. I think that we had ran into that last time as well, and you intuitively were like, oh, that's how you do that. And dead on. So in symbols, this is that same 4 rules in symbols. So for any event A, the probability of A is between 0 and 1. If S is the sample space, the probability of the sample space is equal to 1. When outcomes are equally likely, same formula as before. And then our complement rule, P of A complement is equal to 1 minus P of A. Everybody's okay with this? Same thing as the last slide, just in symbols rather than words. Should be able to do both, right? So when we talk about probability, there's 2 different types of probability that we'll talk about. There's theoretical. This will be the one that we'll probably spend the most time dealing with. This is the probability of an idealized situation and the results that should occur based on the given information, where the probability is calculated just the number of possible successful results divided by the total number of outcomes in the sample space. So when we talk about calculating the probability of flipping 2 coins and getting like heads and tails, we're doing a theoretical calculation, right? We know that we assume the coin to be a fair coin, and the probability should behave as such. What if we don't know the coin is fair, and we want to determine if it's a fair coin, or if it's not, what is the probability of heads versus tails? Here we could do an experimental, or calculate an experimental probability. So if in the case of deciding whether a coin is fair or not, we might flip the coin 1,000 times and record how many times we get heads and how many times we get tails. So we could use that to then say the probability of heads would be the number of heads divided by 1,000. And if that's 500-ish, we can probably safely assume the coin is fair. If it's way out of whack, we can probably assume that this coin is unfair. It's weighted, to either one head or tail. Let's see. Another example of an experimental probability might be a baseball player's batting average, right? Like that's computed over the course of a season over, 400 or 500 at-bats. Yep.
For the example, what would be like a successful try?
So if we're just trying to decide whether a coin is fair or not, we just might count the number of times you get heads. So we'd say the probability of getting heads would be, like say it's 650 divided by 1,000, in which case, well, doesn't seem like a fair coin to me. That's what I mean. So in the case of a baseball player, successful trials would be hits, at bats where you get a hit. Cool?
Yep.
Cool. All right. So just to kind of keep moving along, talking about theoretical versus experimental. So the first situation says a baseball player has a batting average of 250, meaning that he has safely hit the ball and reached base 1 out of every 4 times he steps to the plate. In a particular game, he has gone to the plate 3 times and not reached base. Your friend argues the baseball player will absolutely safely hit the ball and reach base at his next at-bat. Give 2 reasons why your friend is wrong.
Because I would at like 3 sets. That kind of makes sense.
If you can't go stop.
So you're talking about like the myth of short run regularity, right? That the long-term probability should match the short term, which we know is not true. Okay. What else? What is the other argument you could make for why your friend is wrong? So here we're muddling. Your friend could be muddling the difference between an experimental and theoretical probability. The batting average is based on past results. That's an experimental probability, right? Predicting using that is now using that probability in a theoretical nature. Like using that then to see into the future, which is an inappropriate use of like an experimental probability. You could make that argument as well. The short run is probably the more common argument. Okay. Next, we want to talk about mutually exclusive or events or disjoint events. We say 2 events are mutually exclusive if they have no outcomes in common, and that means that they can never occur at the same time, i.e. the probability of A and B occurring at the same time is 0. So an example of mutually exclusive events, a very simple example, is heads and tails. You flip a coin and you can't get both, right? Say you're drawing 5 cards out of the deck and you want like, let's see. The probability of drawing let me think. A face card whose value is 7. So there's face cards, and there's cards whose value is 7, but there's no face cards who has value 7. Like those would be mutually exclusive as well. Does that get the idea? So if 2 events have no outcomes in common, the probability that one event or the other occurs is the sum of their individual probabilities. So notice that this is the or situation as opposed to the and. If you're looking at probability of A or B, and these are mutually exclusive events, then the probability is just going to be the probability of A plus the probability of B. Remember, or and union mean the same thing.
If it's or, why can't it be either one?
Right. So it's because we're starting with mutually exclusive events. If they're not mutually exclusive, this OR calculation is not just probability of A plus the probability of B. And we'll look at that in a moment. Okay? So it's the assumption, if I wanted to calculate the probability of getting a face card or a card that has value 7, it would just be the probability of getting a face card plus the probability of getting a card that's 7, because there are no probability of getting both, right? So it's just going to be one or the other. Can't have both. Now, if you can have both, the calculation changes.
Where would it be that you could have both?
Drawing a card that's a face card and a heart, right? Because there's Jack, Queen, King of Hearts also. So that's an example of something that's not mutually exclusive, because there are things that are both hearts and face cards. Does that feel good? Okay. So let's look at some examples. So here it says, when people create codes for their cell phones, the first digit follows the probability model shown in the table below. So 0.09, the first digit is a 0. 0.1, the first digit is 1. 0.2, the first digit is 2, et cetera, et cetera, et cetera. So we're going to find the probability that the first digit is 1. What would that be? 0.3. Just use the table, right? Okay. The probability the first digit is more than 5. So what are the digits that are more than 5?
6, 7, 8, 9.
So we want the probability could be 6 or 7 or 8 or 9. Now, are these mutually exclusive events? Because that's going to change the way we do the calculation here. Can the first digit of your cell phone password be both a 7 and an 8? No. They're mutually exclusive then, right? So if I want the probability of this B, then I just add up the probability of 6, 7, 8, and 9. I get 0.221. Is everybody okay there? But before I did that, I had to ask myself, are these mutually exclusive, and justify that to myself before jumping into the calculation, because you're going to run into situations in the not too distant future where you can have, overlapping events. And it's be very important that you're being careful to think about whether these events are overlapping or disjoint. The probability the first digit is odd. So that would mean we could have 1 or 3 or 5 or 7 or 9. Again, all disjoints, we just add those probabilities. We get 0.603. Everybody's okay? So far, so good? Find the probability the first digit is 1 or greater than 5. So I'm just going to do the probability of A plus the probability of B. Right? We calculated both of those two things earlier. So we can just add those two together. And get 0.521. Everybody's okay with this? Find the probability the first digit is not 1. Well, here I'm going to use the complement rule, right? This is the probability of A complement is what we're asked for. So I'll just do 1 minus the probability of A. So 0.7. I could have also added up all the probabilities for 0, 2, 3, 4, 5, 6, 7, 8, 9. That'd been correct too. A little more time consuming, but not incorrect. Does everybody feel good so far? Okay. The probability that we have an odd number or a number greater than 5. So we'll add up 1, 3, 5, 6, 7, 8, and 9. Those are the odd numbers along with the things that are greater than 5. So here we had to be careful because these two events were not mutually exclusive. They weren't disjoint. First digit is more than 5 and the first digit is odd. Well, 7 and 9 are included in both of those two events. So rather than just adding these two probabilities together, I had to do this separately. Is everybody okay with that? So when you look at these probabilities, just as an aside here, unrelated to what we've been doing, what are the two most likely digits? One and 2, right? Those are the two most likely digits to use. Why do you suppose that is? How many digits for a standard iPhone password? 4. What 4-digit number would be quite likely to be used that it starts with either a 1 or a 2? I would say birth year, right? Like a birth year, like a date. You know, most people with a cell phone are either born, starts with a 19 something or a 220 something.
That really a question you would ask.
No, this is just the weird, like I look at this data and go, why 1 and 2? And my brain starts churning and think, maybe it's birth year or something, like a year thing. Okay. So the other way that you could approach this problem, rather than going and adding these things up individually, you could have taken probability of B plus the probability of C and then had to subtract off these ones that we counted twice, right? So the probability of B counts 6, 7, 8, and 9. The probability of C counted 1, 3, 5, 7, and 9. We've counted 7 and 9 twice. So we could use the probability of B plus the probability of C, but we'd have to subtract off those two probabilities we would have counted twice. What do you notice that the probability of 7 and the probability of 9 are in a set, like in set notation? Since they're in both set B and C, that's the probability of B and C, or B intersect C. Oh, that was it, huh? That's my whole thing. So we'll see that next time when we fully develop this formula. But that's going to be the standard. Any probability of a union is going to be the probability of A plus the probability of B minus the probability of B and C, or I'm sorry, A and B. And it still works for mutually disjoint events because what's the probability of A and B in a disjoint event? 0. So it still simplifies down to the formula we saw here in today's lesson. So far, so good? Everybody happy? Let's do our in-class examples here. So below is a probability models for students who took the 2013 AP Stats exam. Prove the model is a legitimate probability model. To do this, we need to do, what things do we need to show here?
That it has a 1.
Okay, that's one of them. Does it? Yes, it does. What else would you need to check? All the probabilities are between 0 and 1, right? Those are really the two biggies. Okay. Yeah, that's fine. Find the probability that a chosen student score is at most 2. What does at most mean?
The highest.
Okay, it means like less than or equal to, right, is the way I would think about it. So that should be the probability of now, are these events mutually exclusive? Yeah, right. You can't score a 1 and also score a 2 on the same test. So it's just going to be the probability of 1 plus the probability of 2, which is 0.423. Find the probability that a chosen student score is at least a 3. What does at least mean?
Less than.
Other one.
Greater than.
Yeah. Again, mutually exclusive, so just probability of 3 plus 4 plus 5. When I do that, it's 0.547. No, that's not right. 0.577. Just adding them up. Everybody cool? Hopefully what you're starting to see this chapter is like all the computation that you're going to have to do is going to be really simple. It's just going to be like adding and multiplying, but you have to know what, like the words make a big difference as to like what you're adding or multiplying or, subtracting or whatever. All right. It says there are 30 students in a stat class. After taking a poll, the teacher discovers 20 play an instrument, 18 take art, and 12 do both. Construct a Venn diagram for the situation. Okay, so there's my Venn diagram. To fill in, it says, where do we start when we fill in a Venn diagram? The intersection, good. So there's 12 need to go in there. So we've placed 12 in the intersection. That's already 12 in I. So it says 20 students play an instrument, so we need 8 more. And if we do art, it says 18 take art, but we've already placed 12, so put a 6 there. Part B then says, one other thing. What have we forgotten to do? Yeah, how many should be placed? 30, right? How many have we placed? 26. Where those extra 4 have to go? Yeah. Everybody's good? Okay. How many students take art but do not play an instrument? Mm-hmm. So the little N on the outside like that stands for the number of things in the set. So that's take art and and not an instrument.
We have to write it out.
Nope, but I want to make sure that like you're comfortable reading it either way. You could write it in words, would have been fine. So again, the part that's in art but not in I is that piece, which is the 6. Again, I won't ask you to take words into sets, but it's a useful skill to have, at least if you're able to read it both ways. Next example. What is the relationship between educational achievement and home ownership? A random sample of 500 U.S. adults was selected. Each member of the sample was identified as a high school graduate or not, and a homeowner or not. The two-way table displays the data. Use symbols to define all possible events for the data above using high school graduates G and homeowners H. What else do we need though? Okay, what symbol would I use for that? H complement. And what else do we need? Okay, what symbol should I use for that?
G.
Yeah. Feel good? Okay. Suppose you choose a member of this sample at random. Find the probability that you choose a high school graduate. So we're looking for probability of G. How many graduates do we have? 310. How many total people did we talk to?
Is it just a fraction like that, or is it a decimal?
Fraction is fine. You could turn into a decimal if you wanted to. You don't need to. 6.62. Huh?
Would you just know that?
Well, if you multiply the top and bottom by 2, it's out of 1,000 then. So 620 out of 1,000 is 0.62. Because I'm a math teacher. Yeah. Next one, we want that the randomly chosen individual is a high school grad and owns a home. Good. Out of what?
310.
Mm-mm,
500.
500. So 0.442. Okay. The probability that we graduate, our high school graduate or own a home.
High school graduate.
429 is correct. So 310 plus 119 over 500. So you want all the graduates, and then you need all the homeowners that are not graduates.
Oh, you just add those?
And you just add them up. Yep. So 0.858. And then it says, using the two-way table above, construct a Venn diagram, which contains high school graduates and homeowners. Okay, where do we start labeling? The middle. What number goes in the middle? Great, that's correct. So those are the homeowners and graduates. Okay. Where does the 89 go? Yeah, that goes over here. And then how about the 119? Okay, and then the 71. Everybody feel okay there? Now this type of problem, going back and forth between a two-way table and a Venn diagram, which should be something you can do, right? Not difficult, but if you haven't done it before, it's one that you might have to think about there. All right. Well, that's all I have for 8.2. I don't know that I want to go bulldozing forward and do 8.3 right now. Do you guys need to do that? Okay. Okay. Well, let's do this just to make sure I have enough time later on this week. Can I show you guys a little bit of how to do the equation stuff in Word right now, and we can follow up and do some more later on? Okay. So I would invite you right now to take out your tablet so you can follow along.
So the next part of the IA is the
Correct. Yeah. We're going to do the calculations together. That'll be the next piece. And after that, it's just the turn-in.
We're done writing.
Well, no, the part after that, you have to write it and turn it,
Okay.
Yeah. So before we talk about this, while you guys are getting your stuff out, I want to point out the criteria that are used to grade these. So what we're going to be working on right now is going to be, one of them is going to be the communication piece. So I want to just go through the criteria. So A 0 is the exploration does not reach the standard described by the descriptors below. 1, the exploration contains some relevant mathematical communication which is partially appropriate. 2, the exploration contains some relevant appropriate mathematical communication. 3, the mathematical communication is relevant, appropriate, and mostly consistent. 4, the mathematical communication is relevant, appropriate, and consistent throughout. So, to describe what they mean by mathematical communication means that you have used appropriate mathematical language. That means notation, symbols, terminology. Calculator and computer notation is acceptable only if it is software generated, so none of that for us. Otherwise, it is expected that students use appropriate mathematical notation in their work. So when you show, for example, how we're calculating things like a mean or a standard deviation or the p-value for a chi-squared test or something like this, or the chi-squared calculated value or something, you have to type this out. You have to write this out using real notation. Okay? Define key terms and variables where required. This is a place where before you start putting stuff into a formula, you're going to want to say, now I calculated the mean for, my data set. I calculated the mean by using blah, blah, blah formula, and now I'm going to define each of the variables inside of this formula, right? Where xi is each of my measurements and n is the number of measurements, or whatever you need to say. You use multiple forms of mathematical representation, such as formula, diagrams, tables, charts, graphs, and models where appropriate. The last one doesn't apply to you because it's where none of us are proving anything. The thing that I want to make mention of here now is this word consistent. What does consistent mean? Every single time, right? If you're saying the mean and you sometimes use x bar and sometimes you use something else or sometimes you use a mu or same variable, same way through, right? In particular, the thing that I see students have problems with every single year is when you're writing chi-squared, many students will just use an x there. The symbol chi is not an x. Chi is a Greek letter. It looks different than an x. The person looking at yours and grading your paper, me, knows the difference in typeface between an x and a chi. I will notice. We'll talk about how to generate that symbol here in Microsoft Word in a moment. But this is the place where we're going to be working on, is just to make sure that you can get a decent score in this category. Everybody's cool? Okay. The other piece that I want to look at here is on the internal assessment kind of writing guide. So what we're going to be doing is we're going to be working on our mathematical processes section here today. So inside that section, you should have the calculations with proper work shown. The only exception is when you find a p-value, and we'll see that in a moment. Formulas need to be written with variables only first. All variables and associated terminology should be fully defined prior to using the formulas. Correct work and solutions for every mathematical process is shown. Explanations for every major result as it relates to your overall conclusion. And each process should be fully completed and explained before starting a new process. That means don't jump back and forth between doing two things. Like if you're going to do like your chi-squared test, that means you would have had to calculate your means before that, right? Or whatever. Or if you're doing a standard deviation, you need the mean. You have to do the mean before you do the standard deviation. You can't be like inside of the standard deviation calculation, then talking about calculating a mean, and then going back to the standard deviation after you've calculated. You know what I mean, guys?
So if we want to put like my mean is this, we have to say calculate my mean, like this is how
I'm gonna do some typing here in a minute and like let you guys follow along. So the big thing here is the thorough explanations, like you need to explain. You probably mentioned already in the introduction briefly, like what calculations you're planning to do and what they're going to show. Here you would want more explanation, a little bit more thorough explanation. I have, before starting any major calculation, provide a paragraph to describe what the calculation is, why you are using it to prove your hypothesis, and then what the results could show. Then, after every major calculation, take a paragraph or two to explain how the results correspond to your overall statement of task. This means that you do this after doing the scatter plot, the correlation, and the chi-squared test. Okay, those are your three major calculations you're doing. You must show your work. Recognize that showing work for 70 plus data points is excessive. So just show the work for the first 2, 3, 4, whatever, and then use a ... to indicate you did the same thing for the rest of your equation. If your equation has less than 10 calculations, type everything out. Again, before showing your work, make sure you type out the general equation first. This means the equation you would use with the variables plugged in for your data. Remember that your math will be checked, so make sure all numbers you've used are correct. Make all the final answers rounded to the appropriate number of significant figures. Also, make sure your math matches the answers you write, i.e. the numbers you type are the same as the numbers generated in Excel. We haven't done that yet, but the one exception for showing your work is finding the p-value. When showing this in your write-up, say that you took your chi-squared value and found the associated p-value. Don't say that you used your calculator or Excel, even though that's what we actually do, what we'll actually do to find that value.
So what do we say?
So just say you took your chi-squared value that we'll calculate, we'll show the work to do that, and found the associated p-value. That's all you need to say. You don't need to, don't say you did it, how you did that, just say that you did it is enough. Okay? Everybody feel okay as I read through this? When you actually look at the other, yeah, that's the good one I want, right? Oh, so the other place you might want to look to is if you look at the very first IA document, when you look at part 4 or part 5, when you're doing the final, again, I have like everything for each section kind of all detailed together about, even in more detail than I just went through, about what you need to have. Okay, so as you're writing, make sure you're looking back at these things. But let's get to this now. So I'm going to open up a fresh Microsoft Word document. I would encourage you not to use a Google Sheet or a Google Doc to do this. Google is, their equation editor is terrible, frankly, and it's not going to look good. And if you're transferring back and forth between a Word document and Google Doc, the Google Doc's going to mess up all your Word calculations formatting and make it a pain in the butt to fix. I would do my entire write-up as a Word document, just as a suggestion. And I need this over here for me. All right. So what we're doing is the section we're working on is the mathematical processes. So I'd have like a little title or whatever. And then I'd have some kind of start. I'm not going to start it for you. I just have like blah, blah, blah.
What do you mean by start?
Well, like you have some kind of introduction about like next thing I did in blah, blah, you know, like I'm just going to have like blah, blah, blah here. And then, you know, like I started by calculating the mean for both my independent and dependent variables. I denote the mean for the independent variable as, and then what symbol did we typically use here? X bar. So to get that X bar in, what I'm going to do is I'm going to go and press the insert button, or the insert heading. I'm going to go all the way over to the right where it says equation. I'm going to click on that. That's going to open up the equation editor. So these are all my options in the equation editor. To get the bar above, I want to pick the accent option. And then I'm going to look for the one where the bar is above. That's the option right there. And click it. And then using my keyboard, I'm going to move my cursor so that the little gray box with the bar above it is highlighted, and just type an X. And then press the right arrow until it's no longer, until I've exited that equation editor. And I'll say n the mean for the dependent variable as y bar. So I'll do the same thing. I'll do insert, equation, accent, and then the bar option, and then type in the y bar. And I'll say where, and I'll do a colon. And now I'm going to type in the formula for x bar and y bar. So again, I'll go into the equation editor, and I'm going to type in the general formula here. So I'll start with x bar, so I'll do accent bar x. And then I'm going to use my right arrow so that I'm still inside the equation editor, but no longer inside underneath the bar. Then I'll type equals. And then I want the summation notation for the formula. So I'm going to pick the large operator option. And the option I want here is this first one, or this second one here, the summation with limits. So my lower bound is going to be I equals 1. My upper bound is n. So I just use my arrows to move around. And then inside the sum, I want the fraction. So I'm going to pick the fraction option. I'm going to pick the first one. I want the vertical fraction. The denominator is n. And the thing that we're counting here is going to be the xi's. So to get a subscript, to type in xi, I'm going to type the script button, pick the subscript option, and then just type in xi. And then I'll just type and then if I highlight it and just unitalicize it, it'll be like a regular typeface and then I'm just going to update the x's into y's.
Do you just copy and paste the?
Yep, that's all I did. You could retype it, you know, go through all the menus and stuff, but like, oy, 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 that's a lot of stuff. And then I'll say, so I have that, and I'll say and n is the number of samples, but now remember n is the script n, right? So before I type n, I don't want just like a regular typeface n. I want it to look the exact same. So I'll go back to insert, equation, just type my letter n. So it's the fancy script n. Is the number of samples. And then I need to say xi and yi. So I'll go equation editor, script, or subs.
How'd you get the special line again? Script.
I did nothing. I just went into equation editor and typed an n and then just exited out. So I would say xi and yi are like the ith sample in our data set. So again, I want that I to be script, so I'll go back into equation editor, choose the superscript option, type in the th. I'm going to unitalicize the th.
The second part is not in X and Y bar, those are bar.
Right, the xi and yi, those are these symbols right here inside the summation, right?
Yeah.
That's what I'm talking about.
That's the script, subscript.
Yes, exactly right. Yep. So this is me giving the formula with nothing filled in, defining what all the little pieces of the formula are. What I want to do next then is to actually put my numbers into the formula, right? So we'll say the means for my data set are, I'll press enter, and I'll go back into the equation editor, and I'll write x bar equals, and I'm going to do a fraction, and I'm just going to make up some numbers here. So like 8 plus 11 plus 1 plus ... plus, I don't know, my last one, let's say, is 2. Oops. And then, I don't know, let's say I had 54 thingamajiggers. Yes. Yeah. That probably helps, right? Yeah, just ask if you need it zoomed in. And I'll do the same thing. Oops. And I should say that this is a value. Let's say this is approximately something or another. So to get the approximate symbol, if I look here in this big bank of values here, there's the approximate symbol. And I'll say that's, I don't know, 4.76 or something. I'm just making some numbers up. What do you notice about the 4.76 though? How many sig figs? 3. Not an accident, right? And then we'll do the same thing. We'll say like y bar equals, and I'll do my fraction, and just making up some numbers here. These aren't coming from anywhere in particular, just some like made up numbers.
For the formula, numbers equation above.
Well, the sigma symbol means a sum, right? So that's what I'm doing. I am using that formula above. Notice the dot, dot, dot. Totally fine to do that. In fact, you should. Nobody wants to see like 70 numbers added together. Like, they don't care. You'll be supplying your raw data elsewhere in your project. If they want to check it, they can check it. But we'll check it in Excel. As long as you don't copy anything down wrong, you can be fine. Okay. Now, the mean is not a major calculation. So you don't need to analyze what this means at all, unless you feel like it has some kind of significance. So I'm just going to say then I calculated the population standard deviation for both the independent and dependent variables, denoted, and then I want that sigma x and sigma y were the standard symbols we used for standard deviations, right? So I'm going to go ahead and press the equation editor, and now what I'm going to do is I'm going to hit the drop down on this. And if I look there, the Greek letter sigma is one of the shortcutted ones, so I'll pick that.
Hit the drop down on what, the big table here?
Yeah. Oops. And then if I do like shift and the minus sign, they give me the subscript bar, and I'll just type in X and press space bar, and I forgot to do the subscript, so I'm gonna do a keyboard shortcut. Should have done that first. And then do my little droppy drop. Do. So do that, right? Everybody's okay? If you're following along. Okay, now I'm going to type in the standard formula the formula for standard deviation. So I'm going to do it once for x and another time for y. So I'll start with just sigma x equals, and then the formula is 1 over n, and then I have the square root, and then I have over top of the sum, and I have I equals 1 to n of the xi minus x bar squared And then I'll just, once I got it in there, I'll just copy and paste to change the x's to y's.
So how do you get the big square root over the?
So you just type your fraction 1 over n, and then you just pick the square root option, and then put the sigma underneath it, and it'll automatically format the square root to be.
So then write it all first square root
Yep.
and then put sigma.
And then under in the box, you'll put the sigma in there, and it'll automatically make it, stretch it out, and make it big so that it looks nice.
And that's large enough.
And then you just kind of just keep going. You know what I mean? Now, notice before, what have we defined already symbol-wise? We've defined that x bar and y bar are means. We've defined that xi and yi are the ith measurements from the data set, and n is the number or the sample size of our data set. Those are the only symbols in this formula. Do I need to define them again? We do not need to do that. We've already done it once. If you did it again, that's fine. It's not wrong to do that. You would not be graded down for doing that. I'm going to skip doing that because we've already done it. And I'm going to show how I do this calculation. So again, I'm going to start with like sigma x equals. And then I'll have the fraction. So the n that I was using was 54. I'm going to want to double check to make sure I've typed in the same number everywhere through here. And I gotta do a couple of these. Oops. So my first sample was 1 and my mean was 4.76. And my second sample was 11, and my mean was 4.76. My third sample was 1, my mean is 4.76. My last sample was 2, and my mean was 4.76. And we should say this is approximately, make up a number, 3.14. That's a fun number. And then I'll just do it again. You guys feel like this is helpful? Would you have known what to do with any of this? Yeah. And this is a nice skill to have. If you're in a next year in college and you're in any kind of class where you have to do some kind of lab report or something like this, whoever is in your group will be really excited that you're able to do this kind of, make it look nice and pretty, even if you have to kind of like stumble your way through it again, where it's like, at one point I did know how to do this. 1.8 is my next one. Yeah, I mean, this is like, it's not hard, it's just like a time suck,
Yeah.
which is,
Keep messing up like little formatting stuff.
yep. It's like, once you got the hang of it, you understand like what you know, like how far over you need to go or whatever.
Yeah.
But it just takes like some time.
I made like the whole thing small and I didn't know that.
So just to note, Colin, like if I'm outside of the equation editor, I press like a space bar.
That's what I did.
So if you just delete what you just
Yeah,
did,
figure that out.
yeah, it'll just put it back.
Until after, so I just put it back here.
Yeah, that'll work too. Yeah, like undo or whatever. Yep.
On the right side of like the large operator, is that like, do you do like the script, the superscript and then subscript for the Y, like YI?
Yeah, so what I did is I did the superscript,
Uh-huh.
and then I did the parenthesis,
Yep.
and then I did the subscript, and I did minus, and then the bar. And pretty typically, when you build these things, you kind of want to build it from the outside in.
Yeah, I kept going like in the line and I realized it was supposed to be superscript.
Yeah. If it's honestly easier to do this in code, but nobody wants the learning curve of like figuring out how to do this all like without the word overlaid on top of it to do the typesetting and the formatting and stuff. So like when I had to write, like when I wrote my dissertation, and for most of really grad school, when you do this sort of stuff in a mathematics class, you'll use like a program called LaTeX. But basically you're formatting a document like through source code instead of like the word overlay on top.
What's the difference between source code and like source code just made like regular like
So like I am typing like, instead of this, I'd write like, you write like slash, instead of this piece that's gray, I do like slash sigma subscript, like below x equals frac bracket 1 frac or bracket 54 bracket equals,
all that stuff.
like I just do it all from the keyboard, so I can just type and type and type. And then when it compiles, it builds it and it looks
Yeah.
the way I want it to.
That's kind of what we have to do. See if computers like that.
Yeah, it's so you're building it out rather than using like a visual editor. You're using like, I'm just doing it by code, and then it compiles it to hopefully what I want it to look like, and then you never get it right the first time. You have to go back and figure out like, oh boy, where'd I drop a parenthesis at, or like, yeah.
That's most annoying to me. For that equation right there, is that just like random numbers, like whatever your
Yeah. What if I made up here, Colin? The 8, 11, 1.
Yeah, I just wrote like blank, blank, blank. Plus
Yeah,
something.
yeah, that's fine. You'll fill them in on Wednesday after we do this. Okay. So far, so good? Okay. We can always pick up more on this on Friday, too. There should be time to do a little bit more here, typing wise. But this can be like really kind of a time-consuming pain in the butt if you haven't at least done it a little bit yourself. But Word makes it fairly easy to get, get what you want out of it. It's just time consuming because it's all menus.
Yeah, instead of just being able to type it out.
Yeah. So I'm going to stop the recorder here because I won't do anything more. We got 5 minutes left is all. But we'll pick up